Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 11 of a unit motion in a straight line. So let's begin with today's class. Today we are going to discuss about the integration part 2. If you remember in the previous class we were discussing about the basics of integration, and we have already discussed about the various basic formulas that we are using in the physics. So let's look at those formulas and we'll be shifting to today's class. So let's look at this. These are the formula that we have learned in previous class. These are the basic formulas of integration. We know that integration of x to the power n dx, it is x to the power n plus 1 divided by n plus 1 plus c. We know that this c is a constant, and this is applicable. This is applicable unless n is equals to minus of 1. Second formula, it is integration of e to the power x dx, it is an e to the power x plus c. The third, integration of 1 by x dx, it is an ln x plus c. These are the basic formulas. Now let's look at the trigonometric functions. Integration of sin x dx, it is of minus of cos x plus c. Integration of cos x dx, it is a sin x plus c. Integration of sec square x dx is equals to tan x plus c. These formulas are not limited to this. That means integration does not contain only these formulas, but we are learning a certain formulas which we are going to use in class 11 and in class 12 for part of physics. So we are going to learn only those formulas only which are going to be used in physics. Now let's learn the all those formulas which we are going to use in physics. So before we go through the integration, first tell me, do you remember this acceleration is equals to dv by dt? Yes, a is the acceleration and v is the change in velocity, that you know. So if yes, can I write like this? It's a dv is equals to a dt. Yes, if I integrate this on both the sides, if I integrate this on both the sides, what this will come? It's a, let's say this is u, this is v. When initial velocity is u, time is 0. When initial velocity is u, that time is 0, and this is t. So if I write this is integration of dv, this is v, and I need to put a limit v to u. This is integration of a dt from 0 to t. So what I can write is it's a change in velocity, or even you can write it as an v minus u is equals to integration of a dt. If it is a definite integral, I can put a limit from 0 to t. So this is my first relation. This is my first relation according to the physics of integration. Are you done with this? Let's look some new formulas. Let's have a look. You know this v is equals to dx by dt, where v could be speed or velocity, and x could be distance or displacement. So if it is there v is equals to dx by dt, what we can write is dx should be is equals to v dt. If I integrate this on both the sides, if I integrate this on both the sides, it would be an delta x. That will give me an integration of v dt. So this is delta x, that could be equals to integration of v dt. Are you done with this? Are you done with this? Yes. Let's have a one more formula. acceleration is equals to v dv by dx. Is it there? So if I write as an a dx, that should be is equals to v dv. If I integrate this on both the sides, if it is there, now what is integration of v dv? Yes, you are right, it's a v square by 2 minus u square by 2. This is equals to integration of a dx. So let's rewrite this. It's a v square minus of u square divided by 2 should be is equals to integration of a dx. So this is my third formula. So do you remember each and everything? Yes, my first formula, it is delta v should be is equals to integration of a dt. Second formula, delta x, that would be equals to integration of v dt. And my third formula, v square minus u square by 2 is equals to integration of a dx. Now if let's summarize this. If I write a summary of this, a first formula, it is delta v is equals to integration of a dt. Yes, our second formula was delta x should be is equals to integration of v dt. A third formula was v square minus of u square by 2 should be is equals to integration of a dx. Yes, if you understand this very carefully, then can you find something very interesting? Do you? Do you find something very interesting? Let me show you. I know that a is equals to delta v by delta t. Yes. So even I know that delta v is equals to a into delta t. If I write this in a differential term, it would be a delta v is equals to integration of a dt. Yes. Of course. Just observe and tell me your tell me what is your conclusion. We know that v is equals to delta x by delta t. We even know that delta x is equals to v into delta t. So if I integrate this, then I can have delta x is equals to integration of v dt. Yes. Now what do you conclude from this? What do you conclude from this? Yes, first tell me where we are going to use differentiation. Yes, you are right. When I need to divide two terms, when I need to divide two terms, and if their segments or their parameters are very small, I was using differentiation. But but when when I require a multiplication of two quantities, when I require multiplication of two quantities and their segments are very small, then I'm going to use an integration. So the thing should look like this. Let's say you are having a distance or displacement, and you require a velocity or speed, and you are having a velocity or speed and you require an acceleration. Things would be look like this. So what I should mark you is, if you are having a distance or displacement and you need to reach to the velocity or speed, what will you do? Yes, you will differentiate this. If you are having a velocity or speed and you require an acceleration, you need to differentiate this. But if you are having an acceleration and you require velocity or speed, then you need to integrate this. This is integration. If you are having a velocity or speed and you require distance or displacement, then you need to do integration. So a first point, moving forward. If it is a task of moving forward, then I need to differentiate. Second, moving backward. Now you understand that what is forward, what is backward, because we have already used this kind of things in graph as well. It's a moving backward, it would be an integration. Shall I add something this too? Shall I? Yes. You need to differentiate. If it is a division, then I need to go for differentiation. If it is a multiplication, if it is a multiplication, then I need to look for the integration. So please do remember these things. Please do remember this. Yes, one more thing I want to relate is that let's say this is some certain kind of graphs are there, and graph of distance or displacement versus time and velocity is required. What will you do? Yes, you are correct. You are going to find it out, the slope of the graph. Let's say you are having a graph of speed versus time, and you need to find out the acceleration. Yes, at that point of time you were considering that shall I move forward or backward. Acceleration, to find out the acceleration I should move a forward, and that would be an slope of the graph. But if I have been given a graph of acceleration versus time and I require, let's say, speed versus speed, then I need to move one backward, and to move a backward I need to find it out area of the graph. If I am having a graph of speed versus time and I need to find out the distance, what you should do? Yes, you need to find out area of the graph. And when that area is something like that, that you cannot directly calculate it by simple geometry, what you should do? Yes, you need to integrate it. Yes. So can you complete all the dots? Are you able to do this? Are you sure? Yes. Moving forward, it's a differentiation. Moving backward, it would be an integration. If I need to divide two terms, it would be a kind of differentiation. And if I need to multiply two terms, it would be a kind of integration. So are you done with this? Are you sure? Let's look at the numericals. They said that acceleration of a particle is given as a is equals to 4t plus 3 meter per second square. Find out velocity of particle. Find out velocity of particle for first 3 seconds. This is the question. Now think it and react to it very carefully. This is acceleration. What you require an velocity. How can you do this? How can you do this? I am having a relation of delta v should be is equals to integration of a dt. Now if you are thinking that I will do something like this, v is equals to a into t, this is not possible. This cannot be done because this is non-uniform acceleration. We are going to learn about this uniform acceleration and non-uniform acceleration, but at this point of time you just remember this, that this approach is not possible. So you need to integrate this. So let it b integration, it's in 4t plus 3 dt. So that would be is equals to, that would be equals to 4t square by 2 plus 3t, and I need to integrate it from where to where. It's a first 3 seconds, that means from 0 second to 3 seconds. So let me put up the values. So it would be, and delta v should be is equals to 4 by 2, it's a 2 multiplied by t square, it's a 9 plus 3 into 9 minus of, minus of, this is 0, let us put, would be a 0 plus 0, that would be a 0 only. So this would be 2 9s are 18 plus 3 9s are 27. So 27 plus 8 35, 35 plus 10, it's a 45 meter per second. This would be your answer. Are you sure? Did you get this? Did you get this? Yes? Well done. So if I add something to that question, to the previous question, that in previous question, find displacement of particle in first 2 seconds. Now you require a displacement. In the last numerical you have already done up to the velocity, so let's first write it down, that delta v is equals to 4t square by 2 plus 3t, and that means I am having an, it is a 2t square plus 3t. So I am having an velocity and I require a displacement. I am having an velocity and I require a displacement. What should I do? Shall I move forward or backward? Shall I move forward or backward? Yes, I shall move backward. So when I move a backward, I need to integrate. And if I need to integrate, let's do it. That delta x should be is equals to integration of v into dt. That should be is equals to integration of 2t square plus 3t dt. From where? In first 2 seconds. So that should be begin with 0 and end up by 2. So that would be is equals to 2 into t cube by 3 plus 3t square by 2 from 0 to 2 seconds. So if I do this, that would be is equals to 2 by 3 t cube, it's a 2 multiplied by cube plus 3 into 2 square minus of, let 0 be replaced, it's a 0 plus 0. Yes, so this would be is equals to 2 multiplied by 2 cube, it's an 8 divided by 3 plus 3 fours are 12. So this is 16 by 3 plus 12. So this is 16 plus 12 threes are 36 by 3. And if I solve this, it's a 36 plus 6, 42, 42 plus 10, 52, 52 by 3 meter. Yes. Are you able to understand this? Are you? Any question? Anything? No? So will you able to solve this kind of stuff? Are you sure? Can you do this? Can you do this? Are you sure? Let's move with the next question. They have given that acceleration of an object is given as A is equals to t plus 5 meter per second square. You have been asked that find out average acceleration of an object for t is equals to 0 to t is equals to 5 seconds. This would be the thing. So how can you do it? Go through data one more time. Go through it. What you have been given, you are provided with the acceleration and it is t plus 5. You need to find out the average acceleration. So first let me know that what is average acceleration. What is it? Yes, it is change in velocity divided by time taken. Average acceleration, it is a change in velocity divided by time taken. When average would be there, it would be a change in the velocity divided by time taken. If it is an average velocity, it's a displacement divided by time taken. So what I need to do is I need to find out delta v, I need to find out delta t. Now delta t, I know that it begins from the 0 and it ended up by the 5 seconds. So delta t would be a 5 seconds. How could I do the delta v? How can I? Yes, I can integrate this because I require delta v. I am having an acceleration. I need to move a backward. To move a backward, I am having an option that I can integrate it. And if I integrate this, things will be done. Yeah, so let's do it. So this average acceleration would be is equals to integration of a dt. Now this is t plus 5 dt from 0 to 5 divide by 5 seconds because it is a delta t. So this should look like t square by 2 plus 5t. Don't make an error that it would be a 0. That was the differentiation. This is integration to the 0 to 5 divide by 5. So if I replace this, it's a 5 squared 25 by 2 plus 5 5s are 25 divide by 5. It's a 25 plus 50. This is 25 plus 50. This is 75 divided by 10. This would be the answer, or you can write it as 7.5. But can you do this kind of thing? Are you sure? Are you sure? Let's move to the next question. This graph is given. This is y. This is x. They said that given graph represents function of y is equals to x square. Find out area of this graph, and they have mentioned that this is 0 and this would be the 4. You need to find out an area of this graph. That means you require this segment. You require area of this segment. How can I do this? Look, this is not a curve where I can simply divide this into certain segments and area would be available. So what options I am having it? I can integrate this, and answer of this integration will give me the area of this graph. So can you do this? Let's do it. This is y is equals to integration of x square dx. That I need to find out an area of this graph. So I need to begin with the 0 and ended up on the 4. So this is 0 to 4. So if I integrate x square, it should be an x cube by 3, and limits would be a 0 to 4. So that should be is equals to 4 to the power 3 divide by 3 minus of this 0 to the power 3 is none of use. It's a 4 cube. It's a 64 divide by 3. It's an area. Units. It's a 64 by 3. It's an area of this graph. So can you solve this kind of graph as well? Are you sure? Are you sure? Can it be done? Can it be done? Are you sure? Will you be? Okay, let's now do something new. What you have given is that force acting on an object is given as F is equals to 4x plus 3 Newton. Due to this force, object has been displaced from x equals to 0 meter to x equals to 2 meter. Find out work done due to this force. Go through this data very carefully. Go through it. What is given and what they require. So what all they given is, they have provided me force. They have provided me that due to this force, object has been displaced from x equals to 0 to x equals to 2 meter, and they want me to find out work done. So first you must consider that do you have any relations that can relate work done, force and displacement? Do you have anything? Do you have? Yes, it's a work done is equals to force into displacement. But can I do this directly? Can I do this directly, that I simply multiply 4x plus 3 by 0 or 4x plus 3 by 2? Is it possible? No, it is not. But after knowing this relation, I am pretty sure that I need to do a some kind of multiplication, and when I need to do a some kind of multiplication, I can relate these things with the integration. Are you able to get this? Are you sure? Any problem? Any problem? No? Yes. So let's move on. What you need to do is you need to find out the work done. So can I write like this? It's a integration of f dx. Yes, so I need to integrate this f. It's a 4x plus 3 dx from 0 to ended up by the 2. So if I integrate this, that work done would be is equals to 4x square by 2 plus 3x, and that should be ended up by from 0 to 2. It's a 2x square. 4, this is 2x square, so this is 2 multiplied by 2 square plus 3 multiplied by 2, and this 2 into 4, it's an 8 plus 3 2s are 6, it's a 14. What is unit of work done? What is it? Yes, it is joule. So this should be the answer. Did you tried it? Have you tried it? What was your answer? Is it same? Are you sure? Well done. Great job. Let's move to the next question. They said speed of an object is given as v is equals to 4t square plus 2t plus 3 meter per second, and you need to find it out. First, acceleration of an object at t is equals to 2 seconds, and second, distance traveled by an object in first 3 seconds. Now go through this data very carefully, but make it quick. What all they have given, what all they have provided. They have given me the speed. That speed is something like this. And what I need to find out, I need to find out the acceleration of an object at t equals to 2 seconds, as well as I need to find out the distance traveled by an object in first 3 seconds. So what I can assume it that this is speed, this is acceleration, and this is distance. So to find out an acceleration, I need to move forward, and to move forward I can have an option of differentiation, and to move up backward from velocity or from speed to a distance I need to integrate this. So can you do this? Are you? Let's have a look. What is given? It's a 4t square plus 2t plus 3. So v is given as 4t square plus 2t plus 3. You need to find out an acceleration. It's a dv by dt. So that should be is equals to d by dt of 4t square plus 2t plus 3. So that should be is equals to 8t plus 2. Now differentiation of 3. What is it? Differentiation of 3. Yes, it is a constant, so it would be an 0. I require acceleration at t is equals to 2 seconds. Yes, I required acceleration at t equals to 2 seconds, so it is an 8 multiplied by 2 plus 2. It's a 8 2s are 16 plus 2. This is 18 meter per second square. Yes, this is half of the battle. This is half of the battle. Let's do the remaining task. You have been given v is equals to 4t square plus 2t plus 3. You need to find out the distance, and it can be done with the help of integration. So let's integrate this. It is a 4t cube by 3 plus 2t, it would be a 2t square by 2 plus 3, it's a 3t. I hope this seems clear to you. And where I need to find out, it's a 4 first 3 seconds, so this is from 0 to 3. So let's replace the value. It's a 4 by 3. It's a 4 by 3 into t cube. It's a 3 cube plus this 2 would be a cancel out. It's a 3 square plus it's a 3 multiplied by 3. It is 9. So this is 4 into this is 3 cube. This is 3. So it is 3 square multiplied by 9 plus 9 plus 9. It's a 4 9s are 36 plus 18. And when I add this 36 plus 18, it's a 44 plus 10. It's a 54 meters. Yes. So what was your answer? Is it same? Is it? Are you sure? So can you do this kind of stuff? Will you be able to solve this kind of things at your end? At your end, can it be done? At your end, can it be done? Are you sure? Let's move to the next question and check it out. This is the question which only you need to perform. So have your pen and paper and do it fast. Let's say velocity of an object is given as v is equals to t square minus 4t plus 5 meter per second. Find out distance traveled by an object when acceleration of object becomes 0 for the first time. Go through this. What they have given is that velocity of an object is given and you need to find out the distance traveled by an object, but when you need to find out the distance when acceleration of an object becomes 0 for the first time. So first what I guess is find out at what time acceleration is 0. These are the hints. Find out at what time acceleration is 0. And then integrate this and then integrate this to find distance traveled. Yes, you get this? Yes, or shall I help you for something more? Shall I? Let's look. V is equals to t square minus of 4t plus 5. This is the data that have been given. What I need to do is I need to find out the acceleration first. It is an a is equals to dv by dt. So if I differentiate this, it is t square minus of 4t plus 5. It's a 2t minus 4. I require that acceleration should be a 0. So that I came with the t is equals to 2 seconds. Now what you need to do is you need to find out the x. Then x is equals to integration of v dt. So this is equals to integration of t square minus of 4t plus 5 dt from 0 to 2. Yes, and then you just simply need to integrate this, that is t cube by 3 minus of 4t square by 2 plus 5 into t. Put up a limits and have your answer. So meter. Done? Done? Are you sure? This kind of things can be done. Can you? Will you be able to solve this kind of thing? Are you sure? Let's look at the next and very interesting question. Yes, this is t, this is a naught, let's say. It's an amplitude basically. This is 0. I hope you remember this. You have learned this in ninth class. This is half of the time period. This is complete time period, and from 0 to t, we call it this as a complete cycle. For 0 to t by 2, we call it this as an half of the cycle. And this graph shows sine function. Find out area of complete cycle. That means from 0 to t. Let's say this is y. So what you need to do is you need to find out an area of this cycle. So this function would be y is equals to a naught is the amplitude, a naught into sine omega t. This is they have given, and you need to find out an area of this. So first let me know what you are supposed to do with this and what can be done. Yes, I need to integrate this. I need to integrate this, and my limits will be my limits my limits should be 0 to t. So shall I show you this? Yes, let's begin. Area would be integration of a naught sine omega t. So if I put a naught aside, sorry, dt, this is equals to integration of sine of omega t dt. So this is a naught integration of sine omega t. What is it? Yes, it is minus of cos omega t, as well as, do not forget this, divide by omega. Yes, so let's rewrite this. This is a naught by omega into bracket cos of omega. Omega, what is it? It's a 2 pi by capital T into t. From where to where? From 0 to t. So if I do this, it should look like minus of a naught by omega into bracket cos of 2 pi by capital T into t minus of cos of, it's a 2 pi by t into 0 and bracket close. This is minus of a naught by omega into bracket, this t would be a cancel, so the remaining term would be a cos of 2 pi minus of cos of 0 degree. So this is minus of a naught by omega into cos of 2 pi. It's a cos 360 degree. What is it? Yes, cos 360 degree is a 0. Then cos 0 degree, it, because this is a cos 0, 360, 720 all remains the same thing. So this is cos 0 and cos 0 is 1, minus this is again cos 0, it is 1. So this would be a 0. This is the area. Yes, even analytically, if you have seen this very carefully, you might get this answer, that look at this area. This is somehow positive 1, and look at this area. This is somehow negative 1. This is a2, and this a1 and a2, it is same because this graph is symmetrical. And if it is a symmetrical, then whatever this is positive, this much amount would be always a negative. So positive negative makes it 0. Yes. Okay. So I left with one of the question to you only, that in previous question find out area of half of the cycle. Say half of the cycle, that means from 0 to t by 2. So this is, you need to do it. I'm not going to help you anyhow with this. Yes, so please do it, please. So let's sign off. In this class we have been discussing about the integration for physics, and this is all about the integration as we require according to the physics. This is all what we require in class 11th and class 12 according to the integration and physics. So next time we are going to move with the new topic, but before we go, I request to do practice a lot, because we have completed many important topic of this. If you look at from the beginning, it is the distance displacement, then average speed, average velocity, then it would be a graph, then it would be a differentiation, and now it is an integration. So we are left with the very little topics with this. Yes, we have been left with the kinematic equations and relative velocity, and that's it for this unit. So please do as much questions as you can do. Thank you. Have a good day. Take care. Bye bye.